Hello, welcome to module 5 of our end-to-end data analytics pipeline with Excel. Today's module is on DAX, that's data analysis expression. This module is in two parts, part A and part B. Part A will treat calculated columns, aggregation functions, some selected logical functions, and lookup functions. Then part B will treat the calculate function, other lookup functions, logical functions, and time intelligence functions. This video is the part A of the DAX module. Let's get started. DAX stands for Data Analysis Expressions. DAX is a formula-based programming language used in Power Pivot, Power BI, as well as SQL Server Analysis Services to perform calculations on data models. DAX drives calculations to present data. Actually, DAX is the engine that drives the calculations needed to present data in a meaningful way by pulling the data out exactly the way you want it. DAX formulas are used in measures, calculated columns, calculated tables, and reliable security. DAX is a formula-based programming language. It's intuitive, it's flexible, it's more advantageous and powerful, dynamic than the normal Excel formula. Another advantage of DAX over the normal Excel formula is that it doesn't sit on a constrained cell in Excel, but it sits or works on top of a data model. So we could actually say that DAX extends your data model to answer the business questions or the insights you want to derive from your data set. So DAX sits on top of a data model. Normal formulas cannot work on data model, but DAX sits on top of a data model, extends it, and helps you answer all the metrics questions the decision makers are looking out for. Great. So let's zoom in into the lab section. First of all, we'll have to look at the syntax, then we'll look at the categories, then we'll make our hands dirty. Okay, so I believe we ended last session with our first DAX here. Okay, so I'm going to click on the Power Pivot tab on the ribbon, then under calculations, measures, manage measures. I'm going to click on the revenue measure we created and then edit. Okay, so I've done this. I want you to see the syntax right in action. Okay, so this is kind of quite an advanced DAX for starters. But when you look at this, the ones in green, so this SUMX, okay, is the name of the DAX function. Okay, so actually every DAX formula begins with an equal sign, similar to what Excel formulas does. So the equal sign precedes the function name. So it means that if it's a DAX measure, the first thing that comes is an equal sign. Following the equal sign is an aggregation function or a function. Okay, so here we are having SUMX. As we go deeper, you understand what the SUMX is. So the categories of DAX functions, we have the aggregation function, the math and trigonometry function, financial functions, lookup functions or logical functions, iterator functions. So the SUMX is an iterator function. So iteration in computing means you are iteration in computing means you are running over an item. You are traversing through a set of items. So these iterator functions allow us to compute an aggregated value row by row. Very soon I'll explain why these iterator functions are very powerful and very needful in most circumstances for us as analysts. Okay, then you see others here being the name of the table. Okay, the name of the table. Okay, so let me cut this one and use a simple function called sum. So sum, I want to sum the quantity column. So okay, so quantity is in the others table. Others, yes. Okay, so I have to. Okay, so no errors. So a DAX formula begins with an equal sign, the name of the function. Here you can see the name of the function in green, then in parentheses the table name. Okay, this is optional for measures, and right after this I explain the difference between measures and calculated columns. So you have your equal sign, the name of the function, the name of the table where the column you are going to perform the aggregation on or the calculation on comes from, then the column. So you could actually see, okay, after the column you have your closing parenthesis. You could actually see that whilst I was typing, I never typed the name of the table. So when you type the name of the column, quantity, so as you begin typing the name of the column, okay, this is quantity, you see two options: quantity with a fully qualified quantity, that's quantity indicating the table is coming from, and a naked column quantity which doesn't have the which does not show the table is coming from. So I have two options. Each of them will work because this one is a measure. Okay, so for measures you can avoid fully qualified columns. When I say fully qualified columns, what we are saying is that when you select the column that you want to perform the calculations on, tell us which table is coming from. So this quantity is from the others table. This is a fully qualified column. This one works. When I click on check formula, it works. If I take away the table name, this one is a naked column, and I click on check formula, it still works. Okay, but as a practice, because of what we call calculated columns, sometimes you might have the need to have calculated columns. Calculated columns will not allow you to have naked columns. Okay, it's always have to accept a function name. Then again, for DAX measures, so this is a DAX measure. For DAX measures, you always have to bring an aggregator function or a function. Okay, so I have deleted the name of the function, the sum, from this, and when I click on check formula, I get to see that I say calculation error in measure others revenue. A single value for column quantity in table others cannot be determined. So mostly we use measures to aggregate values in a column, or when you are using the iterator functions, values row wise, a single value. Most often you are looking for a single value, which will be like total revenue. So you look at this side, this here is a single value, this is a single value. So you are aggregating all sales for 2020, all sales for 2021, that retains a single value. So DAX measures retain a single value. For that purpose, you cannot write a DAX measure without an aggregator function, without a function preceding the equal sign. Very, very important. Okay, now what are calculated columns? So you have DAX measures, as I've demonstrated, and they also have calculated columns. So you can actually use DAX in a measure or DAX in a calculated column. What are the differences? The revenue here, as you have all seen, is a DAX measure, and this is what you want your users to see that answers the business logic. The measure calculates on the fly as the user interacts with your dashboard or your report. And is flexible, is dynamic. In other words, if it's working on the fly, it's automatic. Based on what the user is clicking, the result will recalculate and display accordingly. Again, measures are not stored in the table. Okay, earlier on I said that they perform calculations on the fly. So as and when the user wants to find total revenue for a particular year and clicks on it, the measure will be triggered and calculated on the fly for the user. However, calculated columns are stored as part of the table structure. In this regard, calculated columns take storage space. So another word, a simple word for calculated columns is a derived column. Okay, so this one, let's do it together. For calculated columns, we have to create them in Power Pivot window. We could as well create our DAX measures in Power Pivot window, but during the last module I explained that it is not user friendly to create your DAX measures in Power Pivot. More friendly approach is to use the measure window in Excel. That gives you IntelliSense and several aids. Okay, so let's go to Power Pivot. Okay, so you click on your Power Pivot tab on the ribbon, and then under data model, first command group manage. Under data model, we are going to Power Pivot window. So please, let's go there. We should be, let me click on my own. We should be in Power Pivots now. Okay. All right. So let me click on the others. Okay, so kindly click on the others table. I am in table view, so click on the others table. At the bottom section, just on top of your status bar, you can actually navigate the sheet. So each table has a tab down there that you can click to activate. I believe everybody is there. You have activated your others table. Okay, so please, we have started the lab session, so you work alongside with me. All right, now look at the column. Which one is this? The row ID column, the bottom section of the row ID, and click. You could see revenue. Okay, at the bottom. I think mine ends on 648. After 648 or after row 33, could see revenue. Click on it. As soon as you click on it, you see in the formula bar. Okay, so when we go to Power BI, we'll be writing our DAX in our formula bar, just like this. I've shown you one place you can create DAX in Excel, and in fact, when we go to Power BI, you also get to see that we have a new DAX studio, and then another place. So there are two places we can create DAX in Power BI. But in Excel, I think they give us 3 places that we can create DAX. 3 different avenues. Okay, 1, 2, yes, 3 different avenues. The second place we can create DAX is come down here. This area where you see the revenue is called the calculations area. Okay, how do I know it's a calculations area? Watch this. I am moving way up to the home tab on the ribbon, extreme right side, where I see view. So there's data view, diagram view, show hidden, calculations area with an FX on the table. When I click on that, okay, you could see that that section that I was seeing is gone. okay, where the DAX measure revenue was is gone. Now I'm seeing the full table and I'm scrolling down. Okay, when I so you could see it's not activated, it's not highlighted. When I click on it again, you see this thick gray line kind of freezes the row, so you scroll beneath it or behind it, and then there's a dedicated region below it. This area you can type measures. You can type your measures here. That's your DAX measure. Okay, so let's experiment. And you could either type them under one column or move to the particular column where your DAX measure will be and type it there. For simplicity, let's type our own under the rule ID where revenue is. So please click in the cell just beneath your revenue measure. I believe you can see where mine is, and type so the name of the measure first. Let's see, order volume. So order volume, and then for this place, when you are typing, you must precede the name of the measure with a colon. That's the only difference between typing your measure in Power Pivots and typing it in Excel DAX measure environment. Okay, so then you bring your equal sign. Okay, I hope you are following. So equal sign, then the name of the aggregating functions, okay, or the name of your function, sum. And here you see IntelliSense is popping up. The same approach we are seeing here is what we'll be working with. So when you get to Power BI, we'll be writing our DAX in a formula bar like this. Okay, so sum. Okay, when you get here, don't worry yourself typing the full function. So what I'm looking for is sum. I want to sum the quantity column. So, and as I've typed sum, I can see the function I'm looking for being highlighted. So I'll press the tab key to select it, and I press the tab key and it selects it. It opens up, it gives me an opening parenthesis. Then I am going to indicate which column I am going to sum and close the parenthesis. So now our DAX measure, order volume metric, is expecting our column. And remember I explained that DAX measure accept naked column. So when you look at this syntax, it's sum bracket opens column name. It's not even interested in the name of the table. That does not mean that when you bring the name of the table is wrong. It's not wrong. For the sake of writing calculated columns, it's very important if you stick to fully qualified columns. Okay, so quantity, you type the name of the column. So quantity, QUA, and as then I spell the first letters, 3 letters of the measure, sorry, of the column name well, I get an option with all the columns that have those 3 letters. So I have quarter, quantity, quantity. I'll go for the fully qualified. So I'm using the down arrow key to navigate to others, into square parenthesis, square brackets, quantity, then hit the tab key to select it. Then I'll close my parenthesis. Okay, if you want to magnify or make your measure right up bigger, you hold down the control key. You should have a mouse, an external mouse. So you hold down the control key and use your scroll wheel, that ball in the middle of your mouse. You scroll it up and becomes bigger. So this is our DAX measure written right in the formula bar. When we get to Power BI, this is how we'll be writing it. So just to expose you to how DAX measures are written, and you see that the same things we are learning here is what you are going to do in Power BI. Nothing changes. So you hit the enter key to effect this measure that you've calculated. So I've hit the enter key. I think it's processing. Okay, mine is done processing, and then I see beneath my revenue metric I am seeing order volume. So when I expand the row ID column, I get to see that in the calculations area I am seeing the values, one value. And this is very important to understand, that all tax measures return one value, a single value. So the order volume, that's the total volume of orders, is 214,777, and then the revenue is returning 1. However, the flexibility and dynamism or dynamic capabilities of DAX allows us that we can actually slice this order volume down by product category, by region, by month, by year, by several categorical variables. We can slice it down. That's the beauty of it. Okay. Yeah, I think so I'm using another software to record. I'm using two softwares. So if one is paused, the other one will work. Sometimes the internet messes up the FN. So I have backups. Oh, that's okay. That's okay. And so far as money is involved here, Charlie, I have £100 7 here. Okay. All right. Thank you. So you've seen your first DAX in Power Pivots at work. Okay. Awesome. Now we actually came here to demonstrate calculated columns. Understand that DAX can be created in Excel itself. You can create it in Power Pivot in the calculations area. You can also create it directly in the formula bar, 3 ways. But for calculated columns, you can only create them where the table is, only in Power Pivot window. You cannot create them in Excel. Okay. Why would we need a calculated column? Calculated columns will be useful, only useful. So let me give you two instances. The first instance where calculated column should be preferred over a DAX measure is the fact that you are going to use the values of your calculation as filters on your dashboard. If you are going to use, let's say, categories of customers or price categories, if you are going to do that, then it's important, in fact not just important, then what you have to do is to actually create a calculated column so the user can use the values to slice and dice the dashboard or your visualizations on your dashboard. Okay, this means that calculated columns can be used as filters and slices on your dashboard, but measures cannot. The other instance where you have to use calculated columns, by the way I'm explaining, it means that use calculated columns minimally. If we want to go spiritual, sparingly. Okay, that's a King James Old Version, Old Testament English. Okay, so you use it sparingly. Okay, minimally. So the second reason why you would use a calculated column is where your DAX measure is complex. It involves a lot of iterative calculations, or a lot of calculated steps. You are calculating several variables to return the final output, and then you realize that it takes too much time for that DAX measure to load on your dashboard. If it takes too much time, because remember DAX measures calculate on the fly, if you realize your DAX measure takes too much time, then you break some of the calculations into a calculated column which will already be stored as part of the table. So pre-processed and stored as part of the table, and that will make your dashboard very efficient and very fast. If these two instances are not scenarios you are facing, are not issues for you, then do not use calculated columns. In other words, if you are not going to use the values from your DAX calculations or DAX formula calculations as filters for users to slice and dice on your report or dashboard, do not use calculated columns. Again, if your DAX measure does not involve series of complex calculations which takes too much time to load, when a user wants an answer, wants to see some results, revenue by product category, by that, if it does not take too much time to load, okay, in other words, if your DAX measure loads seamlessly when a user clicks on a button, on a slicer, or want to see some interactions, if it works seamlessly, do not use calculated columns. Okay, great. Having said that, let's zoom into calculated columns. See calculated columns at work. Okay, so remember, it's going to sit, or it's going to be part of the table structure. So for this one, scroll to the right side of your orders table and you see add column. Okay, you can see add column there. Add column. Click there, or click, and then, so I've clicked on the first cell under the add column, that faint add column. Then I've typed in the equal sign. Okay, as I type the equal sign, watch what is going to happen. So remember, earlier on I indicated that calculated columns can work without a function. So let's say I want to pull, let me see, which one do I want to pull? Quantity. So I want to have a second quantity column. So I'm going to type the name of the column. So quantity. So as I type quantity, I'll select the second one, hit the tab key, hit the enter key. What is going to happen is that, okay, so it's working on it. I'm reading the status bar, updating. Okay, it's going to pull the quantity column values right here for me. Okay, I hope yours also worked for you. So look at it, calculated column 1. In fact, Excel gave us a column name. We didn't provide a column name, but it gave it to us. Calculated column 1, and see first value for quantity is 2, and first value for quantity correspondingly here is 2. So 2 12 24, 2 12 24. Okay, awesome. I hope it's working for everybody. Yes, so depending on where I will be, my values will be different from yours, but what's important is that what is here should correspond to what is here on the left hand side. And this is just a demonstration to let you know that you can pull the same values from a column here, and by this you can actually pull this and multiply it. So you can go ahead and say, I'm multiplying this one by 0.02, hit the enter key, and it will do the multiplication for you. So this is just to show you this calculation. So this one will make more sense when you want to pick the quantity column or an item, the price column, and multiply by another and get it here. So let's say we want to find the total amount. We will have to multiply quantity by what? The rate. Rate is the unit price. So total amount or total quote is quantity times. So if you want to store that as part of the table, then we'll pick the quantity column and multiply by rate. Okay, so I think we can modify this and work on it, but we'll delete it later. Now we are getting to the DAX proper. Okay, so let's say we want to store the quote as in the total amount a customer is supposed to pay, okay, without discount. So that would be quantity times rate. But look at it, we only have the quantity column here, right? Is that the case? So quantity column, we don't have the rate in here. Okay, so how do we achieve that? So the rate is in the product table. So if you want the total quote, we multiply quantity by rate. So please go to the formula bar, bring your asterisk. So quantity equals quantity asterisk, and then remember when we type rate this is what we'll get. So please, I'm taking my time for you to really understand it, so that when I get to Power BI, I've treated that. So I mean, I'll just give you projects, you design your dashboards, and you are good to go. So really understand that this DAX that you are learning cuts across all Microsoft solutions that has DAX in them. It's the same idea, the same concept, the same implementation. Okay, so I want to multiply this by rate, but when I type the name of the column, it doesn't come. Okay, in normal Excel, you would have used VLOOKUP. The quantity is in orders table, but the rate is in another table. So in Excel, you would have used VLOOKUP to pull the unit price for each item here, so you can multiply. But we are not using normal Excel. We are doing advanced analytics. Okay, so how do we pull the rate column from a different product, from a different table? That's the product table here. That is where our data model comes to save us. So our data model shows us that the rate is in the product table and it is linked. There's a product ID that is linking the orders table. So what we have to tell this calculated column is that there is a related field. So you bring the word related. The related is a function. It's a lookup function in a lookup DAX function. So you type related. Okay, so this is related. And as soon as you type related, now you should be smiling. So anytime you are typing DAX measures or calculated columns and you are using functions and you don't see IntelliSense list of columns pulling up, it means that you are in the error zone. Okay, so related. Now I can type rate and rate will pop up. This basic understanding is really key. Okay, so rate, I hit the tab key, close my parenthesis, hit the enter key, and I wait for it to execute. It's finishing. I'm reading the status bar, says that it's updating. Okay, awesome. So it's done. It's done with the calculations. This is it for the first person. 3410, and this one is stored or is part of the table structure. Okay, it's part of the table structure. We would use the same approach in a DAX measure. So remember, if we do this, you are taking memory storage, memory space. So ideally we would avoid creating calculated columns with these calculations, as far as it's not going to be complex in our report or dashboard. So we would use a measure for it, but I want you to see how calculated columns are done. That's why we are doing like this. So we have to name it. To name it, you can either double click here the column name and change it to, so quote, hit the enter key. This related is not linking. It is telling the engine that the other column is coming from another table that is already, like they are brothers, they are siblings, they share a common field. That is related. So it's telling that quantity is in this parent table that I am in, orders. However, the product, the rate, okay, so quantity is in the orders table. However, rate is coming from the product table, which is sharing a common field with the others table. So this related is not building a relationship. It's telling Power BI or Power Pivot that it is the relationship exists. So execute the relationship between the others table and then the product table. Please, is that clear? Thank you. So this related here is doing the VLOOKUP approach in Excel. So you are looking up a value here. In fact, thank you for that question. So that could even lead us to the next implementation. So watch this. Remember, the rates are not part of the quantity column. So we can use a related function to put the respective rates from the product table right into the others table. After the quotes, please, in the next column, the add column, type equals related and then type rates, that's the name of the column, close the parenthesis, hit the enter key, and you see that the corresponding rates for each product or each business transaction will be displayed there. So that's it. Okay, what we have just done is to pull the rate values from a different table, that's the product table, right into our others table. That's what we have done. So that's what the related does. The related looks at a particular value in this table in your data model and pulls its corresponding value from the other table. Okay, so let me even let you do this. In the next 3 minutes, display the first names of the customers. Okay, display the first name of the customers. Okay, please, I am done. All right, time up. I am done. Who had it? Yes, who got it? Who got it? Who got it? Yes, 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 please. Please, who was able to do it? I don't know if you realize how I did mine. I did it straight away in the formula bar, just like we did the DAX. So I typed the name of the column, the column, customer name, colon, then equal to, and that in full. Okay, but when you are done, it will separate the name of the column. If it's a calculated column, to put the name of the column here at the left side of the formula bar, and then your function in the right hand side. Okay, you can type the name, the full DAX formula right in the formula bar. So my own, I type customer name, colon, then equal to, like this. If I type it like this and I execute it, what Power Pivot will do with the DAX engine is that it will put the name of the column, the customer name I type to the left of this. So to the left of this FX and then the correct here, you see customer name. This is the name of the column. So the name of the column will be to the left here. Okay. That's what I was explaining. Okay. So we are doing the last calculated column. Then we'll move to our DAX measures. That's where we're going to spend most of our time there. Okay. Now, what if we want users to be able to slice and dice our report or dashboard based on the rates? So we want to make sense in our pricing, the rates that we have in the rate for our products. We want to intelligently calculate or determine which product is premium and which product is standard. Then we want to also find out the total revenue premium is given for a particular year, particular month. The total revenue standard is given, like, but we want to give the users access to this on the dashboard as a slicer. Okay, to do that we have to use calculated columns. Okay, calculated columns. All right, so remember we want to assign a text label based on different rate values. Now we want to use two conditions. If the rate is greater than $200, then the product is premium, but if it's between 150 and 200 is standard. Any other one is basic. So we are going to use this logic to create a calculated column that will return these categories: premium, standard, basic. And by this we can filter or slice and dice it on our dashboard. Okay, or we can actually create a pivot table, per pivot table, and see how much revenue these three categories are giving us. And remember, this is what we are going, it didn't come ready with the data set. We are creating it, making sense out of it, creating a category. Okay, so click on the add column, first cell under add column, then go to your formula bar. Please, this one, do it with me, no going back. Then type the name of the column. So rate category, and then your colon and equal to. I'm waiting for you. Colon and equal to. By this time you should be here with me. To do this, we could have used the if statement, or if function. Sorry, it's a logical function, but a better option for the if in this case is the switch true. So we are going to use the switch true DAX functions to achieve this purpose, and it's not difficult at all. Okay, so we'll start with the switch. So you type switch, tab to have your opening parenthesis, then type true. Okay, and the true will open and close the parenthesis. Okay, so it says switch, then expression, value 1, result 1, ... and then you provide your x. Our else will be our basic. So switch true, comma, then now you look at the syntax: value 1 and the result 1, value 2, result 2, value 3, result 3. Okay, now what we want to look at the rates, and then if the rate is greater than $200, then we say that it's premium. If it is greater than 150, it's standard. Else it is what? Basic. Okay, so what do? We need to bring the rate column. So you type rate, and fortunately for us, we have the rates put up here, but let's pull the rate from the, we are pulling the rate from the product table. So rate, so you comma related, then you type rate. I believe by now you understand it. So the only function you are using for the first time is a switch true. Okay, so rate or sum. Okay, so we have it like this: greater than 200, comma, in quotation marks. So premium, comma. So you would realize that there is a red underline on the rate column and the products table. That is because the related function has to receive a closing bracket after the column input parameter. So to fix this, place a closing parenthesis after the closing square brackets of rates. Then related rates. Okay, then greater than 150, okay, comma, standard, okay. So it's left with our else. We only have three pricing categories: premium, standard, basic, and we have satisfied the first two. So the last one will be any other one that is below 150. So between 150 and 200 will be standard, below 150, greater than 150. So 150 and below will be what? Basic. So that will be the else. So you just put it in quotation marks and you are good to go. Fortunately, I don't have an error. I hope everybody too doesn't have an error. Okay, so I'm going to hit the enter key to execute. It's executing. Fantastic. Okay, mine works fantastically well. Okay, I believe yours too is working fantastically well. The beauty of this is that now we can slice and dice our revenue or any of our metrics based on these categories. Okay, based on these categories. So if it so happen that the standard is giving us more revenue rather than the premium, then we have to focus more on middle pricing. Okay, so we can get a lot of insight from this. This one takes us or brings us to not an entirely end of calculated columns, but for demonstration purposes, by now you have solid understanding of calculated columns. So we switch to DAX measures. Thank you. The ones that will not be part of the table, to not be stored as part of the table, it will sit it somewhere. When the user calls for it, then it will be displayed for the user. Okay, so as we practice more, you really have conceptual understanding of how each of the DAX functions work. Okay, please make sure you have saved all the things in Power Pivot. So my save, I believe my own is saved. So my saved icon is not active. It means that I have saved it. I have saved every changes that I have made. So I can close Power Pivots. Okay, so please close the Power Pivot window, and now you should be in your Excel window. Awesome. So we are going to do our DAX measures. So all is set for DAX measures, and these DAX measures helps us answer the metrics, the questions the metrics decision makers make decisions on. Okay, and they get calculated on the fly. They are not part of the table structure. They get calculated as and when the user triggers them. Okay, fantastic. So let's make our hands dirty. Remember, we have a sales metric sheet. We will come back to this sheet, okay, to perform all the metrics that the sales manager will be interested in using DAX. Okay, but for me to introduce you to DAX proper, we are going to create another sheet, and that sheet we'll call it aggregation DAX. Then when we are done, we'll do about 5 aggregation functions, 5 or 6. When we are done, we'll come back to the sales metrics sheet and calculate all the metrics that the sales manager will be interested in. Okay, all right, so please create a new sheet, click on the plus icon, new sheet, call it 1 point aggregation DAX, bracket opens, bracket close. Remember, brackets opening and closing is function. Okay, I will color my sheet tabs now because I have more than one. I'll use deep green for the sales metric, and then I'll use deep blue, yeah, for my aggregation DAX. Okay, all right, so everybody is set. We are set to go. You are going to really enjoy this section. All right, so we'll do our setup. So for our setup, we will not type anything in column A. So right click on column A, column width, and then 2.43. Remember, we've not forgotten. No. Okay, so I know you know this, so I'll do it fast. Also do it fast. Then click on row number 5. Row number 5. And you go to the home tab on the ribbon, styles, sales styles, heading 3. Heading 3. Fantastic. Okay. Alright. So let's make our hands dirty. The aggregates or aggregation functions or aggregators, DAX functions, are the sum, the count, the COUNTROWS, the main, the max, count blank. These are aggregation functions, DAX functions. In other words, they aggregate a value. When we say we are aggregating, it's like pick the whole quantity column and give me a single value. So please take note that all DAX measures return a single value. That is why they require an aggregation function. A function that will traverse through your column row by row or column wise and compute one value, the total number, the total value, the total number in terms of count and all of that. Okay, awesome. Okay, so let's start with sum. So type sum, bracket opens, bracket closes in cell C5. Sum. Okay, so it means that we are going to demonstrate the sum DAX function here, right here in Excel. Okay, now we don't see our pivot table fields panel or pane on the right hand side because on this sheet, that's the aggregation DAX sheet, we have not created a pivot table. So let's create a pivot table. Remember, our pivot table is going to sit on a data model. So technically, it's going to be a power pivot. So the difference between pivot table and power pivot is that power pivot is a pivot table that sits on a data model. In other words, a normal pivot table will have a single table. If you have ever worked with a pivot table before, you see that when you create a pivot table, you see only one table on the right hand side. But power pivot would show you two or more tables, either related or unrelated. During the last module, we saw how we could create a power pivot table. So please, for your sake, I might call it pivot table. No, for your sake, let me call it power pivot table. Yes. So here, pivot table here means power pivot table. In other words, a pivot table that sits on top of our data model. Okay, so we learned in the last module how we could create a power pivot, okay, pivot table from power pivot window, where right in power pivot window we went to the pivot table and we created a pivot table and brought us to Excel. Today we are going to create the power pivot table or a pivot table based on the data model right in Excel. Great. So please click on the insert tab. Then you see pivot table. Click on it. Click on the down pointing arrow. Okay, the chevron, the down pointing chevron. Then I am using 365. So I have 4 options. I have from table or range from external data source, from data model, from Power BI. You might not have from Power BI if you are not using 365, but you should have from data model. Okay, so please let's click on from data model. Now you understand the difference between the normal normal pivot table and this pivot table we are going to create. Okay, so click on from data model. Cell C6. Okay, yes, and it goes there. Okay, so ideally there's supposed to be two rows. Okay, two rows above your pivot table. So our active cell was C6 and the pivot table got inserted in C6. Let's create two additional rows above our pivot table, this blank pivot table. So please let's create two blank rows on top of our blank pivot table report. So right click on row 6, that's the number 6, and then insert 1 and then insert twice. So insert twice. Okay, insert. So it means that you have row 6 and 7 blank, and then your pivot table will be on we'll start from row 8. All right, now what we're going to do is that we have to clear the formatting, this blue line. So click on number 6, hold down the shift key and click on number 7 so that those two rows will be selected. Okay, then under the home tab, under editing command group, you click on clear format. Okay, clear format, so that we clear that blue line that is not needed there. Ideally every pivot table should have a name. You should name them. So you can see that in my preview I have pivot table 7. That's the name. For the purposes of this demonstration, we will not name them, but when we switch to the sales metrics, every pivot table we'll use in our metrics calculation, we will name them. Very important, because that's what we are going to use to build our dashboard. If you don't name them, you will know which pivot table is performing which metric calculations. Okay, awesome. But for this introduction to aggregation DAX functions, we'll just let the names be like this. Okay, I left these two rows at the top because when we are doing pivot table, we are using pivot table for analysis, and we bring filters. The filters take two rows. So always when you are creating pivot tables, you should leave two blank rows on top of your blank pivot table. This is my blank pivot table, and I've left two rows on top of it. Very important. The other key thing before we zoom into the DAX is that we are going to use several pivot tables from left to right. We will not do it top down, we'll do it from left to right for each DAX measure calculations that we're going to learn. And so you have to leave 5 columns. So from here I'll do 1 2 3 4. On the 5th one I'll type my next DAX function. Okay, so let's even do that before we zoom in. So type count. Okay, count here. So the you should leave at least 4 columns between each pivot table. The reason is that if you are too close, they will overlap and you will have issues. Okay, so at least 5 or 4 columns between each pivot table. All right, now let's make our hands dirty. Okay, So we are going to create, we have already created a volume, order volume measure. Okay, that's great. So even though we have order volume as a measure, we are going to create another one, right? So please click on the Power Pivot tab on the ribbon. Please follow. See there, we're going to papa. So please do as I do. Power Pivot tab. Then under calculations command group, click on the down pointing chevron icon beneath measures, and then new measure. So this is the next time I only say go create a new measure or invoke the measure creation dialog box. So please, it's Power Pivot, then calculations, new measure. Okay, awesome. So this is our measure calculation, somewhere like mini studio or dialog box. Okay, the first thing at the top is the table name. That's the table where your measure will be stored. And for conventional purposes, mostly you store your measures in the fact table, and in this case our fact table is the orders table. So we are going to store all our DAX measures in our orders table, and that's what is selected by default. If yours is not like this, please select the orders. So you can click here and then make sure it is the orders table that is selected. Then the second parameter is the name of the measure. You see why I prefer this interface for creating DAX to the Power Pivot window one. This one breaks the thing step by step and gives you further features at the bottom here too. Okay, so measure name, let's call this one total order volume. I'm using Pascal, no spacing. Pascal, total order volume. Remember we have one that is order volume, so this one we added total to it, total order volume. Then this is optional description, but for your future self, if you write any complicated DAX measure, describe what that DAX measure is doing. So a simple description could be, this measure calculates the total order quantities. Okay, total order quantities. That's the description, what it does. Then we come to the formula box where we will actually type our DAX and check if it's working properly. So we want to sum the quantity column and get one value, that's an aggregate value. Okay, total order volume. So the name of the function we will use is what? Sum. So you type sum, and as you type sum, IntelliSense will pop up. You see that IntelliSense will pop up with the various DAX functions that begin with the word sum or has the word sum of the letters SUM in it. So sum, summarize column, sum X. What we are interested in is sum. So you make sure sum is highlighted out of the options. Press the tab key. Then the name of the column. Which column do you want to sum? You want to sum the quantity column. So you type the name of the column. As you type the name of the column, the name of the table where the column is coming from will also pop up and you select it. So you don't type all in full. Just target the column name, and you could even see the syntax, column name. So I'm going to type quantity, and as I type quan, I see others quantity and quantity. I've explained that for measures you can do naked column, and a naked column is a column that does not show its parent table. But for the purposes of calculated columns, we always want to stick with fully qualified column names. So I'll go for the one with the name of the table, that's others quantity, by hitting the tab key, close the parenthesis. So I am done. This is going to sum all the values in one column and give me one final value. This is what DAX measures, or the measures, are great at. They work with column context. They understand column context, whilst calculated columns understand row context. But along the line, we see how we can make use of DAX measures to also do row-wise computations. Okay, when you are done with this, you click on the check formula to check if your formula works correctly. So when I clicked on the check formula, I see this green check mark telling me that, Charlie, everything went well. Green means you're good. And then there's this error or information box, no errors in formula. Oh, Charlie, congratulations. If you didn't have any error, you're really a data analyst now. Now, this is not all. You come down to the formatting options. This is one of the beauty of using this feature to write DAX. So formatting categories, formatting options, sorry. So come to the formatting options, click on the number. Remember, this is going to be a number. It's not currency, it's number. So number, and orders, we can have 1.5 order. So what you do is that you change this one to whole number on the right hand side. Click whole number and then check the use thousand separator. Okay, I believe nobody will bring me back. So everything is done now. All right, then you click on OK. Click on OK, and you would have your metric visualization. So this one could actually be total order volume metric. Okay, but we are not just learning DAX, we are also learning DAX for analytics, displaying insight from the data. Okay, so we have this. What else can we do with this one number visual, one number value of a total order volume of 214,777? We can actually slice this one down by different products that are there. How many orders did we get for each of the products that we have, or each of the services? This is where it gets very interesting and nice. Okay, so we go to the product table, and because we have a very fantastic data model, it's going to just be seamless, fluid, like that. Open up the product table and then drag product name to the rows area. Product name to the rows area. Now you get to see that the 21477 is being sliced into the different products or services that ML Analytics offers, the different training programs that we offer. So for business analysis, we had total request or order in 2,128, business intelligence, like that, data analytics 30,000, like that. So one figure, we have sliced and diced it. Okay, somebody will ask, why do we have to go this length of writing a DAX for this, whilst we could have just dragged the quantity column to the values area or the values well in Power BI to have it calculated? The advantage of this is enormous, and you will see it today as we keep on exploring. The way to go is to always write your own measure. Okay, now in the measures, we have what we call implicit measures and explicit measure. Now watch this and do same. Yes, that will explain the difference between implicit and explicit. So go to the, open up the orders table, open it up and drag quantity below, drag it to the values area below total order volume. Okay, all right, then you will see two columns in addition to the products. So total order volume and sum of quantity. Okay, now if I give you portfolio projects, design dashboard, and I see your metrics calculation or your metrics visual, I see that you have sum of quantity. Okay, something like this, I will straight away know that you didn't use DAX. This is amateur. This is a normal, I nearly said a first degree or diploma employee. So this is what a normal Excel user would do, but you are not a normal Excel user, you are a data analyst, and for that matter you have learned advanced Excel. You have to create your own measure. So this sum of quantity, the values are the same in it, so 6578 is the same thing here. This is what we call implicit. So the implicit measure, pivot table or power pivot in Power BI creates the measure for you. It creates it for you. So when you drag a numeric value to the values area or values well, a measure is created for you automatically. That measure is called implicit, implied by default, is created for you. The one you create yourself using DAX functions is what we call explicit measure, and that is the way to go. So you can do what we call DAX trees, measure trees, and do a lot of analysis, month on month, year on year, quarter on quarter comparisons, and all of that. Okay, this sum of quantity, you cannot use it in another calculation, it's just stuck here. Okay, so the way to go is to create your own measures all the time from today. All right, so please take off the sum of quantity. To take it off, you have two ways. One way is to click and drag it off the wall to the Excel sheet, it will go away. Another way is to click on it and then you see an option here, remove field, it will also go away. So two options. Fantastic. This pivot table, the layout is not that beautiful, so what we're going to do is that we're going to change the layout. Ensure that you are within any cell in this pivot table, then go to design tab on the ribbon, design tab on the ribbon, and layout, you see reports. So you have subtotals, grand totals, reports layout. Open up reports layout and then click on show in outline form. Show in outline form. Alright, what this does is that the row labels, that's the product name, this row here, okay, the row label, the name, the original column name will be displayed on top of it, and this is very nice, useful, and fantastic. The next housekeeping that we will do before we move to the next implementation is to change the pivot table style. So with business analysis active and then my design tab on the ribbon active, I'll move to pivot table styles. I'll open it up and then let me look for this. No, okay, this is green, this is blue, not bad. Check this. No, okay, I like green. Okay, so I'll go for light green, pivot table style medium 14. I believe everybody can see that one, medium 14. So I'm going for this. Okay, so this is my pivot table report. All right, maybe the last thing, then we'll move to the next one. Now, last housekeeping is this, the display name. So this is product name, this is total order volume. If I want this one to show order volumes without with spacing, without changing the name of the DAX measure, all that I do is I click on this. I'm in cell D8 where total order volume word is on my pivot table report. Then I'll go to the formula bar and then I'll delete the total, space the order, and add S, order volumes, and then it will become like this. By this, I've only changed the display of the metric or the DAX measure name for this pivot table. I have not changed the name of the DAX measure. Very, very important. Okay, now we are going to the next one, which is count. To do that, click on business analysis here, then Control A. So we just make a copy of this pivot table for the next implementation, and this pivot table will be independent of the new duplicate or the new one, the copy we are making. So Control A will select the entire pivot table. Please make sure you click anywhere in the cell, specifically business analysis, and Control A. It will select the entire pivot table. Then Control C, and then on K8, remember we are putting it on what, row 8. K8, hit the enter key and then double click to expand. Okay, all right, so the next one, we want to count the total number of products for each product category. How many products or services do we have per product category? So to do that, we'll take away the product name, and then, so please, we are working on, so remove the product name from the rows area, put product category rather, so product category on the rows area, and then take off the order volume. Take off the order volume. Okay, so you should have your pivot table set up like this. It will create a measure so that we can count the number of products we have for each product category. Okay, now, yes, W, do you have any issue? Yes, W. Okay, so yes, please. Ebia, me drag it. Yes, 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 please. Yes, please. Sorry. Pivot table. And nothing will be there. Then drag product category to the rows area. So we are going to create our second DAX measure. So please invoke your DAX measure window. The name of the measure is number of products. Number of products. And then remember, this is demonstrating the count DAX function. So you type count, okay, like this. And what are we counting? We are counting the product names. Count text, right? Count. Okay, so product name, hits the tab key, close the parenthesis, and have it. So you could see that the name of the tables are being put in single quotes for you. Okay, and as a practice, always ensure that your table names don't contain spacing. Okay, all right, so equals count product name. I'm going to check formula. Fantastic, it works for me. I come to the formatting options, number, whole number. I know the products are only 17. They are not in hundreds, they are not in thousands, so there will not be any need to use the thousand separator. So whole number. So you really have to understand your data model and the data you are working with. Then I'll click on OK, and it should do the visualization for me. So consulting has 4 different products, development has 9, training has 4, and the total number of products is what? 17. So let's do a simple one. The next one is count row. So you come here and tab 1, that's 2, 3, 4, 5, and type count row. Count row. I think it's an X, count rows. Okay, and make a copy. Make a copy of the counts pivot table and paste it under count rows. Now for this, you will need a blank pivot table, so drag products off, drag number of products off. We just need to know the total number of customers. So you drag everything off and you have a blank pivot table like this. Okay, and for me, so check everybody, we are going to use a different way to create the DAX. Right click on your orders. When I right click on my orders, I get to see add measure. Do you also see add measure? Yes, feedback. Okay, so Kingsley sees add measure. Who else? I want you to be conversant with this, because when we get to Power Pivot, we'll have all these options there. We just right click on a table, create measure, bam, and we are good to go. So everything in Power BI is in Excel. Just some few things there that are not here, the cloud capabilities, publishing and all of that. Okay, please click on add measure. So please, let's use this approach too of creating DAX measure. Yes. So by this, I've shown you all the ways, the places that you can create DAX measures in Excel, and the same concept to apply in Power BI. Different places where you create DAX measures. Okay, you see the difference when we right click on the Power Pivots, the table from the pivot table fields, and clicked on add measure. Now it is not check formula again, it's check what? DAX formula. Okay, check DAX formula here. Okay, so this one we want to look at total number of customers. So measure name, we say total customers. Then the name, the DAX will be count rows. The disadvantage with this approach is that you don't see the highlights, the green. If we use the calculations measure approach from the Power Pivots window or tab, you will see that the name of the DAX function will be in green, and then the other column, the column fields or the other ones will be black. But this approach does not do so, but you still get access to your IntelliSense though. Okay, so you could see that the sum and the count accepted column names as the input parameter. Count rows is the only one that accepts table. So you see in the syntax, count rows, bracket opens, bracket closes, table, because it counts the number of rows in a particular table. So the table doesn't really the column does not really matter. We are looking at a table, how many rows we have in a table, and we have a customer table. So we'll go to customer, so we type customer, and what this will do is that it's going to count the total number of rows in the customer table for us. So this is it, count rows, customer. Then we come to number, the category here, number, whole number. Customers are companies. We can't have half a company. So whole number. I know they are 100, but if you have an idea that they are in thousands, then you can use the thousand separator. Okay, they are just 100. So whole number. Then you click on OK, and you should see the final value. Okay, we have to apply it. So we open it up, total customers, drag it to the values, and we see it there, 100. Okay, 100. Awesome. Let's do the last one, then we'll zoom to the sales metrics. Okay, so let's do the last one, then we'll move to the sales metrics proper. Okay, so the last one, we want to find out the customers that we have per the sectors of the industry, the sectors. Okay, so 1, 2, 3, 4, 5, and then we'll call this one distinct count. So there's a DAX function called distinct count. Okay, so do that, then make a copy of the COUNTROWS pivot table for distinct count. So I'm waiting for you here. Okay, then you pull off, then you bring in sector to the rows, pull off the total customers. So you set up your pivot table like this. I believe everybody has been able to set up the pivot table like this. What is left is to create the DAX that will distribute the customers among these sectors, so we can know which of the sector do we have the most customers, or our customers are coming from. We understand the sector and serve them better. Alright, so to do that, whichever approach you want, for this purpose I'm going for the new measure approach. This is very helpful for me. I get to see, so I use this to create, and I use this one for measures that are lengthier and I need to be guided, and I use the right click for simpler measures. This is simple though. So this is called total customers, total distinct customers. Okay, so I will explain the difference between this one and the count row. We use count row for the total customers. This one is still going to give us total customers, but it is going to distribute them among the various sectors. Okay, so you come to your formula box, distinct count equals distinct count. The customer ID is the one in the orders table. So customer ID here is what will enable us to count the distinct customers and be able to distribute them over each sector or product category. So I'll do this, I'll check the formula. I don't have any error. Okay, Then I'll come to the formatting options, number, and then whole number. I'll click on OK. Awesome. So total distinct customers. I think I did some wrong. Distinct. Okay, so you get to see that this one, basic industries is 1, capital goods is 5, consumer durables is 1, technology is 40. I'm going to I'm going to drop total a minute. Yes, a minute please. So watch this, a minute too. I've dragged total customers to the values area and I'm seeing 100. So everybody is seeing 100, right? Those who are calling me. Okay, so who can share the screen since all of you have the same issue? Share your screen. You are not supposed to get the same value. You are supposed to get a distribution of that because you are using distinct count. You're supposed to share the customers among the various industries. Okay, so hold on. Sir Joshua, please click on data view. Let me check something. And then come to your role ID column, the calculations area, down, calculation, where you have revenue. Click on the total distance measure down there. Let me see it in the formula bar. I've seen it. So you are supposed to use the customer ID in the orders table. So it's still a data model issue, but your DAX measure is really wrong. So I've seen it. So go to the formula bar. You are supposed to use the customer ID in the orders table. I hope everybody can see it. No, don't delete the customer. Delete the customer itself. The customer. That's the name of the table. Delete it. Backspace, and type orders. So there's no relationship between the customer table and the sector table. If there's no relationship like that, you create a DAX measure of this kind and you pull something from sector, okay, and something from others, something from sector, and something from sector and something from customer, it won't work because there's no relation. If I had to give you one value throughout, because there's no relationship between sector and customer, but there is a customer ID and a sector ID. There is a customer ID and a sector ID in the orders table. So we can actually use the orders, the IDs in the orders table to achieve this. Okay. Everybody, the word is orders, so please select orders customer ID. So that was the issue. So my formula was equals distinct count orders customer ID. Knowing well, so it's very important to understand your data model. If you have two tables and they don't share a relationship, you cannot drill down to them. It will give you the same value. Yes, please, I'm sharing too. And this is how come when I put my total customers onto the values area, I get the same value, 100, because Oh no, I typed customer ID in my DAX measure. I typed customer ID and I knew, so this is it, this is my own. So as I type customer ID, I knew that I'm looking for customer ID from the orders table, because yes, the orders table is a fact table, has a relationship with all other tables, and has the foreign keys too in it. So by this I can slice and dice across different tables. And the filter context, so that arrow we saw pointing down to the orders table is the filter context. It flows downstream. It doesn't flow left to right. It doesn't flow from customer to sector, that left to right, because there was no relationship between customer and sector. They didn't share common fields, except I think the location and the region, which is a snowflake data model that we link location to region to the orders table. Okay, very very key. All right, thank God you have experienced this one. So by now you should be able to resolve most of the issues you encounter in DAX. Okay, I think this one will take us to the simple DAX measures. Now we'll move to the really applied DAX measure, where we are going to use it to answer all the sales metrics question for the sales manager of ML Analytics. So please, we have done some DAX aggregation DAX measures or DAX functions. We've done aggregation DAX functions. We are moving to the applied, where we will make use of what we have learned so far to answer the metrics questions that the sales manager will be interested in. So from the day that we're doing that data transformation, we identified 3 key stakeholders or decision makers at ML Analytics who would need insight from this data set that we have. First, we identify the sales manager. We also identify the operations manager and the finance manager. So for the sales manager, we explained that you need you want to understand the sales total revenue by each product category, product subcategory, by region, top 5 performing products, and of course some of the things that the finance manager will be interested in, the month on month, quarter on quarter, he also be interested in. So we are going to use DAX to answer all these metric questions. When we are done, our next module will design the dashboard for the sales manager based on these metrics that we are calculating. Please move to your sales metrics sheet, sales metrics sheet tab. Sure you are there. Sales metrics sheet tab. Okay, so this is where we are. Let me reduce this. Okay, all right, so this is revenue by year, and the metric here, the DAX measure is revenue, so we just want to show the revenue here. So total revenue metric, right? So take away the year from the rows area so that we have the revenue metric displayed there. That's what this is doing. Okay, then we would move to 1 2 3 4 column F and type, so let's type total discounts. I wanted to do the quotes and then we subtract the discount amount, but I can do it in one DAX. So total discount amounts in cell F3, then make a copy of the revenue pivot table in cell F6 like this. So all of these are the one number metrics: total revenue, total discount amount that we give to customers. All right, so new measure, and call this measure total discounts, AMT for amount. You can type the amount in full, total discount given. Okay, I'm waiting for you, giving some space to catch up. All right, so by now everybody is here. Please make sure from this point onwards you are not left behind. The discounts that we give to the customers, remember in our table we have discount PCT, that's the discount percentage. So we gave discount to, some of them had 0 or do. We gave discount to customers. If you want to find how much discount we give to customers, first of all you have to understand the calculation of discounts. So rate times quantity times the discount PCT will give us what? The total discount amount we give to the clients. Okay, however, we know that rate is coming from the product table. Is that the case? So remember the related function that we learned, we are going to make use of it. The other key thing is that the calculations that we are going to perform is row wise. For each row we have to multiply rate by quantity by percentage, discount PCT, like that before we get to the final aggregated value of total discounts given. So in this case we cannot use sum. So if we say sum, okay, you imagine this is sum. The sum is expecting what is the column name? So let's say rate. So type rate. You for shege reason, so I just want you to see how this one is. So type rate and say, oh, we want to multiply rate. So I do this. We want to multiply rate by what? Quantity, right? Multiply rate by quantity, then multiply by discounts. Hey, this is as text. By discounts discount PCT. I'll do this, close the parenthesis. As I close the, as I was typing, so oh, Charlie, this one it looks like to work. As I close the parenthesis, we get to see that oh, it can't, it's not possible. So the sum function only accepts a column reference as an argument. I'm doing all of this so that when you are practicing, you encounter some of this, you have to really understand these calculations is done row wise. Each row rate by quantity by the discount percentage we give to that transaction before it aggregates. That is the end game. That is how our calculation, the discount amount, will be calculated. By this it means that the name of the function should be able to perform row wise traversal. In other words, it should be able to iterate through the rows. Okay, and to help us is the sum x. So the sum x is an iterator function that will be able to help us achieve our aim. Okay, so it says that it returns the sum of an expression evaluated for each row. So sum x understands row context, but sum does not understand row context. It only understands column. One column, then we sum it up. But the sum x, all the functions with x are iterator function. They understand row context. The normal ones without the x only work with column context. Like the sum, we sum the values in the quantity column. That is column context. All right. So sum x, please you type equals sum x. Okay, sum x. I usually tap, so you tap to select it. Then look at the syntax. Okay, so no need to cheer, just understand it, and the IntelliSense will be there to help you. So the syntax says table name, comma, and expression. So the name of the table, the fact table, where the key column or the numeric column is coming from is what? The orders. So you type the orders table, comma, then you see that the under the syntax, the guide, the focus shift from table to expression. So the expression is my formula. How do I calculate total discount amount? I multiply rate by product by quantity by discount PCT. That is my expression. And I know that the rate is coming from the product table. So in order to pull the rate from the product table, I use the lookup function. I use a lookup function called related, and this one will let me pull the rates column from the product table. So please, comma, related, then what am I looking for? Rates. So I'll type rate, it comes up, I'll select it, tap to select that, okay, times quantity. Quantity is already in the parent table, that's the orders table. So type quantity or tab times discount PCT. Discount PCT is already in the main table, that's the orders table. Remember, I'm using fully qualified column referencing. All right, I'll close my parenthesis. If I forget my parenthesis and check formula, it says that the expression is not valid or appears to be incomplete. Now please review and correct the expression. Look at the last sentence. The end of the input was reached. So I should review the expression. So I'll close the parenthesis. Okay, then check formula. Did I make any mistake somewhere? This times, oh okay, I didn't close. Yeah, so related product rates, you close the parenthesis for the related part, please. Okay, check formula and everything is accurate now. So sum x orders, comma, related into bracket products rates, bracket closes, yeah, times orders, times quantity times discount PCT. Fantastic. This is going to be money, and we are not choosing currency. We don't want the currency sign to be running throughout. We want to choose number with two decimal as a decimal, and then two decimal places, and then we'll check the use thousand separator. So we'll come to the formatting options, number, the format, decimal number, two decimal places, check use thousand separator, and you are good to go. You click on OK. Okay, so I'll drag off the revenue from it, and this is our total discount amount. I hope everybody was able to do it. It's getting interesting as we are moving on. So I'll move to column G, and the next one, total quote. Total quote. I'll make a copy of this, Ctrl C, hit the enter key. Okay, okay, remember I said we have to be naming our pivot tables, so we will start naming them shortly. Each one will be named based on the metrics. So this will be total quote calculation. Okay, please, can I make progress? Okay, so I'll drag total discount amount off for the total quote. All right, then I'm very happy. It means that I can increase my pace a little. All right, so new measure. The total quote is just the quantity times the rate. In other words, how much we could have earned as a company if we didn't give the customers discount. Okay, so new measure, say total quotes, total quotes. Okay, and then that one is still sum x, because we have to multiply each quantity by each rate and then get the final value. Okay, so sum x, then the main table is the orders table. Our expression is, we are pulling up the rates column from the product table. Okay, so we use the related. I almost forget to close this parenthesis. Then times quantity. So I'll type quantity. This time I'll not use fully qualified. I'll use a naked column. Okay. Alright, so this is it. Ha! Now it's going well. If you're able to do this, Charlie, you are really a data analyst. Okay, so I'll check formula. Oh, fantastic. No errors in formula. It's exciting. Then I come to the formatting options, number category, use thousand separator, decimal number, 2 decimal places. This is monetary value, so 2 decimal places. Click OK, and this is how much we would have earned if we didn't give our customers this sika, this money. In fact, if we subtract, yes, if we subtract this, so I'm going to look at, if I subtract this from this one, I should get the same value for the revenue. Okay, yes, I should go over the last one. Okay, yes, boss. Total quotes. Okay, where have you typed up to? So now understanding is key. So where have you typed? Can you see? Okay, alright, so please do type it, and then okay, so the next one is total orders. The sales manager wants to see this one number visual, how many total orders that I had. Okay, so make a copy, a duplicate of the total quote pivot table, drag off total quote from it so it becomes a blank pivot table. I believe we are here. Okay, so new measure, the name of the measure is total orders. Remember, this is different from the order volume. This total orders is going to count the unique order requests or other transactions that came to the organization. Okay, so equals distinct count, because we want the unique. Some of the other IDs might be repeated. Okay, so we want to see how many unique orders did you receive, and this one we can even slice it by year, by month, by product category. Several insights can be gleaned from this. Okay, the name of the column is order ID. So equals distinct count order ID, and I'm going for naked column. Okay, check formula, no error. Come to the formatting options, number, use thousand separator, and I'll go for whole number because there's no half order. Everybody orders, every order is a full order. Okay, then I'll click on OK, and I should have my one number metric total orders. The value is 5,496. The beauty of this is that I can slice this by year and I get to see. So there's no end to what we can do with this. Okay, but we are doing one number visual for now. It's DAX. Okay, now let's zoom into the other key metrics. Top 5 performing products. So move to R and type top 5 performing products. After this, then we'll do the time intelligence. DAX functions. Make a copy of the total of this pivot table. Okay, then drag off total orders, so we are setting it up, and put product name. So open the product table up, product name. Okay, so we will visualize each product and then its total revenue, and we'll filter only the top 5. I think we have to do formatting to this, so click on this. We don't want this row label, we want the name of the column or the name of the field. So design on the ribbon, report layout showing outline form, and then of course remember I love the medium 14. Fantastic. I'll click on save. Let me give you some 30 seconds to get it set up like this, then we can make progress. So you go to invoke the new measures dialog box. The name of the measure is top 5 products. Top 5 products. Awesome. Please follow me here. Don't miss any step at this stage. Just na ye catch sa baby aye kwedie. Pacho, we are zooming from here na advanced ni man ye run, really advanced. Okay, so what we want to do is that out of the 17 products that we have, we want to rank them, but we want to rank them by their revenue. So we check your revenue, this revenue that you generated. Out of this, we'll sort them in descending order. So product name by revenue, sorted in descending order. Then we'll filter out only the top 5 in this DAX calculation that we are going to do. So the idea is to rank the products by their revenue in a descending order and then display only the revenues for the top 5. Okay, fantastic. So let me do it straight away. So ideally I would have used the rank for you to see if it is true and all of that, but look at how we're going to do. So please type if. So we use the if function. We're going to use about 3 different functions. So if, okay, if I usually tab. So if bracket opens like this, so please follow. Bracket opens, hit the enter key and then the tab key once. So this is programming, but business programming. So if you tap, hit the enter key, then press the tab key. Now look at the syntax. Logical text, result true, result a false, right? So this is similar to the a function in the main Excel, in Excel. Okay. Now our logical text, we are going to use the RANKX function to pull out the values for our logical text. So we want to look at the product names against their revenue sorted in a descending order, and then if the values are less than or equal to 5, that becomes our logical text. So our logical text is revenue against the products sorted in a descending order less than or equal to 5. So that will give us the top 5. If that is the case, return the revenue. If not, you don't qualify. So rank X, remember all the function names of the X are actuator functions. So rank X, and see that returns the rank of an expression evaluated in the current context in the list of values for the expression evaluated for each row in the specified table. Plenty English. And say a rank the products and their revenues. That's all. So row wise, this understands row context. Okay, rank X. Okay, then we bring another DAX function that is called OR. The OR will reset. Usually when you design your dashboard, there are filters on it. If somebody clicks on a filter, and the filter will trigger all other visualization on your dashboard. In that case, your top 5 metric will not work well if you don't reset any filtering on any other product. So you bring the OR. So OR, this OR returns all the rows in the table, so the original one. Okay, OR. And what are we resetting? We are resetting the product name. So you type product name. This is it, product name. Okay, so by this, regardless of whatever filter that is there, our top 5 products will work well because the OR will reset all products names to their default. Okay, so product name, comma. Okay, then revenue. We have a measure for revenue, so revenue, comma. Now look at the expression in our rank X table expression. Okay, value 1, value 2. So bring comma, and as you bring comma after the revenue, we should see that it is shifted to the value. Okay, now we want to move to the place where we can sort the revenue and the product names in a descending order. So we do another comma. Okay, so can you increase the width of your DAX measure? Okay, please, you have to close the OR. So before the comma, close the before the comma on your right side. Yes, close the parenthesis. Yes, then move after the comma. Revenue. Yes, tab. Okay, comma, 2 commas. All right, I hope everybody's one is resolved now. So this is where we are. You can share. Please, are we all okay now? Okay. So the the syntax is table expression value. The value is the revenue. Then we want to move past. We want to move past the expression is the revenue. We want to move past the value because the expression, the revenue gives us the value itself. So two commas means we are skipping the parameters in the rank X. So one comma will skip the value and the next comma will take us to the others parameter, the input parameter there. So please, you can delete one comma and see. Delete one comma. So you have so you see that the current the active one parameter is expecting is what? Value. But the value is what we will use the value if true to return. So we are skipping the value input parameter. Okay. So the second comma will skip the value and take you to the order, whether in ascending or descending order. This is like okay. Yes, please. So one comma means you are moving from one input parameter to the next. If you want to skip the next parameter, then you bring what? Two commas. Okay. So doing two commas will skip the value parameter and move us to the order. Okay. All right. So please, you can unshare. Then I'll share my own. All right. So now our two commas takes us to the order input parameter. We want it to be sorted in the descending order. So we type disk. This is, if you have done SQL, you see that this is like SQL. And I've said here that if you understand Power Query and understand DAX, you can actually do away with SQL, because whatever you can use SQL to do, you can achieve almost, you can achieve over 99 or 98% of the things with Power Query and DAX. Okay. All right. So DAX will sort in descending order. So by now you close your parenthesis, and all this that we have typed is our logical text. So you can see the if function. The logical text is still the one that has the focus, is deep. So this is our logical text. The logical text is going to pick the product names and the revenues, okay, and sort them in the descending order. Okay, it's sorted in the descending order. All right, from largest to the smallest. But in our logical text, we need to compare it with something. So less or equal to what? 5. This completes our logical text. Then bring comma, and you see that the focus will shift from logical text to what? The value if true, or result if true. If it is true that these product names and their revenue sorted in the descending order, they are less than 5. So we are filtering from first row to the 5th row. What should we display? We should display their revenue itself. So comma, hit the enter key, type the revenue measure or revenue, the measure will come. Remember, this is a measure we've already calculated though. It's not a column. Okay, it's there because during our last module we calculated this. So we've done the value if true. Now we are left with the value if false. Okay, what do we want to return if we don't have 5, top 5? Nothing, blank. So we type the blank function like this, hit the enter key, shift tab, it's not working here. Okay, hit the enter key and then the backspace to move to the end of your function, because you have satisfied all righteousness. All right, So when you close the parenthesis, you see that the opening parenthesis will be, or the opening, or the opening parenthesis, or the one corresponding to the last one will be dim, will blink. Sorry, to blink, telling you that that is its corresponding parenthesis. So we are good. We are done. So click on check formula. By the special grace of God, no errors. Then we have to come to the formatting. Number, use thousand separator, decimal number, 2 decimal places. Click on OK. And see the magic. If you have been able to do this, Charlie, you are bosso. You are bosso. So filtered top 5. The only thing you need to do here is, the last thing you need to do here to make it nicer is to right click on one of the values. I'm using the first one, business intelligence zone, sort from largest to smallest, and you have the top 5. Great. So this brings us to the end of our module on DAX. There will be part B of DAX, which will treat the calculate function and time intelligence functions. Our next module will be dashboard design. Thank you very much.